Well, hello 3C. We're going to wrap up parabolas today by using the important features to talk about applications of parabolas. So our goal, I can use the properties of parabola to answer questions about situations that can be modeled by a quadratic function. Okay, so here we're talking about applications of parabolas, and I'm just going to go over again the most important features of a parabola. The most important features of a parabola are, let's just do our little parabola here. Okay, the most important features are these ones here. The x-intercepts, the y-intercept, and then the point right down in the middle of the vertex. So this is the vertex. We got x-intercepts here, and the y-intercept. Those are the most important features of the parabola, and they answer most of the questions that we want to know about a parabola and things that can be modeled with parabolas. So we can use these features to solve for models. Now I'm just going to read through this nasty bit of text here. It says, when an object such as a ball is tossed into the air, its path can be described as a parabola in which the x-coordinate represents how much time, so the x-axis is time that has passed, after the object was launched, and the y-coordinate represents the height. So up here is the height, H-E-I-G-H-T. Okay. Now I'm not going to put any numbers on here, but I am going to draw the flight of a projectile. Now this happens quite often. I'm maybe actually going to try that again so that I get it on the axis this time. There's our flight of their projectile. And here, which is the vertex point, represents the maximum height, the max height, and that occurs at a certain time down here. So we're going to call this time, well, let's call this H, and we're going to call this maximum here K. And so this vertex point is actually h comma k, which is what we're used to in the standard form of the parabolas. Now this is our beginning point, where it starts on the y-axis is our beginning point or initial height. And down here is when it's on the ground. And that's just what it says down here. The y-coordinate of the turning point of the parabola represents the maximum height of the object. So the y-coordinate, the max height, is the k, the y part, and it happens at time h. The x-intercepts represent when the object is on the ground, and the y-intercept represents the height it was thrown from. Okay, so let's have a look at an example. A cannonball is shot into the air. Its height can be described by this equation, where h is the height in feet and t is the time in seconds. Now here it's asking us, what are the zeros of this relation? Well, it's in factored form, so the zeros are easy. The zeros come from making these two brackets 0. So it's going to be 1 and 9. So if I start doing my rough sketch here, what I find is that this parabola, or this cannonball, was on the ground at time 1 and at time 9. And otherwise it was upside down, and we can see that from the equation too, because that says it's upside down. And it's stretched by 3, but since I'm not putting any numbers on here, we don't really have to show that. Okay. What do the zeros mean in this situation? This is where the cannonball is on the ground. The ball is on the ground. Now it says find the axis of symmetry. The axis of symmetry runs right down the center of the parabola, so it is right between 1 and 9. Now remember how we find that? How we find the axis of symmetry there? We take an average of the two zeros. So average the zeros, and we find the axis of symmetry. So 1 plus 9 divided by 2 is going to be 10 divided by 2, or 5. So therefore, x equals 5 is our axis of symmetry. That also means that this turning point of the parabola is the point 5 something. And that something is going to give us our maximum height. So part D says, use the axis of symmetry to find the vertex. Well, I found half the vertex just by finding the axis of symmetry. Now I need to find this last piece. So that last piece I get by subbing this thing in, and it's actually not an x in this equation, it's a t. So I'm just going to stroke that out with a different color right in t for this equation, but it means the same thing. And I'm going to use that t equals 5 back up in here to find my new h value. So that will give me my maximum height. So h equals -3. I'm going to put that in red, this 5 that we had here. 5 minus 1. And our other bracket is going to be 5 minus 9. Now that I'm subbing it in there, -3, 5 minus 1 is 4, 5 minus 9 is -4, and we're going to get -12 times -4 is +48. So this actually now has a height from part D. That means that this here is 48. So there's our maximum height. Okay, so our vertex is 5 and 48. What does the vertex tell you about the flight of the cannonball? Well, it tells me that after 5 seconds, so this is in seconds, the cannonball has reached a maximum of 48, and this was in feet, so 48 feet. So part E says, and I'm going to scroll this down a bit. Part E tells me the cannonball after 5 seconds, the cannonball reaches a maximum height of 48 feet. And then it says write your equation in vertex form. So we know we want h's and t's, so I need h equals, vertex form has a bracket that's squared, and we know that the thing out on the end here, that plus 48 is over here, so plus 48. In the brackets we're going to have t minus 5. And then this -3 that was right out in front, remember in all three forms, vertex form, standard form, and factored form, this gives us our stretch factor or a value. So this needs to have a -3 out there. Now we can double check this and expand this and factor it again if we wanted to, or we could expand both of them. I could expand this one up here and expand my new one and see if they're the same thing. We're not going to do that. I'll let you do that. You can do that on your own if you want to. We're going to look at another equation here. Example number 2 says on planet X, the height h meters of an object fired upward from the ground at 48 meters per second is described by this equation, where t is a second since the object was fired. Okay, we got to determine the maximum height of this object. It's not in factored form, and we cannot find the maximum height unless it's in either factored form or vertex form. Since it's not in vertex form, since it's not in factored form, we're going to have to factor it. So A, we're going to find the maximum height of the object. The first thing I'm going to do, well, let's actually switch this around. I'm going to put the -16t squared plus 48t out front. And the first thing I'm going to do is take out this -16. Remember when we were factoring, I said we want a 1 in front of t squared, and if it's not there, we got to divide. So I'm going to divide both by -16. So if I take -16, I get t squared minus, and then 48 divided by 16 is 3. Now in this case, I could have taken the t out as well. So let's actually take a t out. So I got -16t, and then if I take one t out here, I only have a t left, and then that's going to be -3. Okay, so there we go. Now, what makes this 0? Because we have to find the zeros of this equation. Now, the zeros of this equation come from when each of the factors is 0. Now, there's no brackets here, but we can understand that it's 0. And what do I have to stick in for t to make this 0? Because we want to find the zeros. Well, this means negative 16 times t, and so I would have to times something by 0 in order to get that to be 0. Now, if I'm going to stick something in here, to cancel out this negative 3, it's going to have to be 3. So there are our two zeros. The two zeros are 0 and 3. Now to find the vertex, remember we have to average the zeros to find the axis of symmetry. Average the zeros. So 0 plus 3 divided by 2 equals 1.5. Now you might have been able to get that right off the bat. If you can, awesome for you. If not, this works every time. And that is going to be the x-coordinate of the vertex. When you average the zeros, this is the x-coordinate of the vertex. And now we need to sub x into find y. Now remember, this thing, we don't have any x's and y's, so we've got to remember which is our x's and which is our y's. Well, the y usually sits out here, so we're still going to call that the y, and the x is usually in here, so we're going to call that the x. So what we're doing is we're sticking 1.5 in for t in this case. So h equals negative 16 1.5 squared plus 48 times 1.5. And we get 36. All you have to do is type that straight into your calculator. Pay careful attention to order of operations, but most calculators will do that for you, so just plug it in. So h equals 36. So that means our vertex, or this is our maximum height of the object. Okay, so the maximum height of the object is 36. Now that was a lot of work to find out that the maximum was 36. We have to find the vertex. So I know now, having done all of that stuff, that the vertex is 1.5 and 36. So that's easy enough. Now it says, at what time does the object hit the ground? I'm going to make a sketch of this object. Once I've got the vertex and I've got the zeros. If you have the zeros in the vertex, I'm going to highlight them. We got the zeros. Now we have the vertex because we found the x-coordinate of the vertex, and this is the y-coordinate of the vertex. Once we have those things, we can make a good sketch of this object. And once we have a sketch, we can answer all kinds of questions. So here's our sketch. Our zeros are at 0 and 3. So there's 0 and 3. Our vertex is at 1.5 and 36. So I'm going to draw the parabola out here. And this point up here is 1.5 comma 36. Which means if I go over here, I have a height of 36. And here's my x-axis. My axis of symmetry. This is the axis of symmetry. Okay, so I've got all these sketched. Now, what is B actually asking us? B says, what time does the object hit the ground? Well, right here, when the height is 0 is where the object hits the ground. So after 3 seconds, the object hits the ground. And what else have we got here? Part C says write the equation in vertex form. Well, we've got all of this out. I know I have, and I'm going to write it with x's and y's. Y equals, we need blank, bracket, squared, and then a blank on the end. And I'm going to fill those in. I'm going to use a different color, just a lighter color of blue here. The number out front here, we're going to get from here, right there, the negative 16. In the brackets, we have x, and since it's been moved forward, it's going to be minus, and we know it moved forward 1.5, so x minus 1.5. And then on the end, we have 36, so we're going to go plus 36. So negative 16, x minus 1.5 squared plus 36. This is vertex form. Now, we didn't have x's and y's in the original, so I'm just going to write it out again here in red. Our y represented height equals negative 16x, well, and it wasn't x either. Where's my eraser? It was time, so we're going to use a t for that one. T minus 1.5 squared plus 36. And so there's our vertex form, where here's our maximum height. It reached the maximum height at 1.5 seconds. And we can use this to figure out where it was on the ground. And we're going to leave it at that.